Okay, first question. We have a product of two expressions. Right side is less than or equal to 0. So first of all, let's have a look at if we can factor each of the expressions. Okay, first, let's consider this expression. 2x squared can be factored to x and 2x. Let's try using the cross multiplication first. Then negative 15, we can try using 3 by 5. And note here we have a plus 1x here, right? So probably you can put a negative symbol here. And then by cross multiplication, we'll get 6x then minus 5x, which is 1x, which is a term in the middle, right? Okay, so basically this expression equals x plus 3 and 2x minus 5, right? We can successfully factor it like this. So how about the next one? So next one, first of all, we need to sort all the terms from the highest order to lowest order. So 2x squared minus 9x plus 10, right? And then let's try cross multiplication method again. So 2x squared can be factored to x by 2x, and then 10 can be factored to 2 by 5, right? And notice this time we have a negative 9x. So let's try using negative 2 times negative 5. The product with two numbers is still 10, but this time by cross multiplication, we'll get negative 4x minus 5x, which is negative 9x, which is a term in the middle, right? So that means the second expression here can be factored to x minus 2, then 2x minus 5, right? Okay, of course, this needs to be done preferably on scratch paper. You don't have to write it here. Okay, so basically the original expression is equivalent to this one less than or equal to 0, right? And this can be further simplified to note here we have 2x minus 5, right? So that's x plus 3 times x minus 2, then times 2x minus 5 squared less than or equal to 0. And note here, the left side is just the product of several binomials. So basically it's a polynomial function, right? Then we can consider this polynomial function on the left. So let's consider the function y equals x plus 3, then times x minus 2, then 2x minus 5 squared. And the discussion is based on this function here. So first of all, let's find its degree. Degree is the highest possible order of x, right? 1, 2, 3, 4, we have 4x. So highest possible order of x is 4. Then let's consider its leading coefficient, which is 1 by 1 by 2 twice, which is a positive number that is greater than 0, right? So basically the end behavior will have a shape like this. Degree is even, leading coefficient is positive, so the end behavior will look like this. The next step is to determine the behavior in the middle. That depends on the zeros and their orders. Next, let's find its zeros and their orders. Okay, so zeros is to let y be 0, right? If y is 0, we can have x is negative 3 with order 1, or we can also have x equals 2 with order 1, or we can have x equals 5/2 with order 2, right? Because this factor has been repeated twice. So this 0 will have order 2. Then based on this information, based on this information here, we can sketch a graph of this polynomial function. So smallest zero is -3 with order 1, then followed by 2 is order 1, then followed by 5/2 with order 2, right? Then the curve will go like this from x, as x goes from negative infinity to the first zero, function will arrive to the first zeros here. And because the first zero x equals -3 has a odd number order, so it will cross this point, then go all the way to the next zero 2, which also has order 1, which has an odd number, so it will cross this point, then to the next point 5/2, which has order 2, right? Order 2 is an even number, so this function will bounce back rather than crossing this point. So this function here has a sketch like this. Then our task is to find any interval that makes this function less than or equal to 0. Okay, less than or equal to, that means below or on the x-axis, right? So this point to this point will do, and also this point will do, right? Okay, this interval will also make this function less than 0. Therefore, the correct solution is x can be greater than or equal to -3 and less than or equal to 2. Or there is another possibility, x can also be 5/2. This is our final solution. All right, have a look at this question and let me know if you finish, okay?
Okay.
All right, let's see the next one. Okay, let's observe the inequality here. Left side is a product of two expressions, right? So first of all, let's check if we can factor the first one, because the second one is already a binomial, right? Okay, first one is actually 2x cubed minus 1 cubed, right? Remember that we can use a cubed minus b cubed equals a minus b times a squared plus ab plus b squared to factor it, right? So this one equals 2x minus 1 times 4x squared plus 2x plus 1, right? Okay, so let's call this a star. Then the original expression original expression asterisk equals 2x minus 1 times 4x squared plus 2x plus 1, right? Then times 4 minus 5x cubed less than 0, right? Okay, next, it seems that we have a trinomial here, right? So for any trinomial, we can convert it to the vertex form and see if this expression is always greater than or less than 0. In order to divide both sides using this expression, right? So let's check what information can we get from this trinomial. So note here, this trinomial is actually 2x plus 1/2 squared, right? We can try using this one. And if you expand it, you will get 4x squared plus 2ab, which is 2x plus 1/4, right? because you have a +1 here, then we have to make up 3/4, right? So in this way, we have converted to the vertex form. And note here, the first part is something squared, which is greater than or equal to 0, right? A number that is greater than or equal to 0, then plus a positive number, then this expression actually always greater than 0, right? So let's call this double asterisk. Then we can say because 4x squared plus 2x plus 1 equals 2x plus 1/2 squared plus 3/4. And this number is actually always greater than 0, right? Therefore, if we divide both sides to the double asterisk, then because this number using this number here, because this number is always 0, that doesn't change the inequality symbol here, right? So the double asterisk is equivalent to 2x minus 1, then 4 minus 5x cubed less than 0, right? In other way, if you have a product of this number, and this number less than 0, if you know this number is always greater than 0, then that means the rest of the product, which is this number multiplied by this number, must be a positive number to ensure the left side is a number that is less than 0. You understand? Can you follow me?
Yeah.
All right, so that means the original inequality is equivalent to this one. So instead of solve the original one, we can just focus on this one because they have the same solution, right? Okay, so now we have a product of several binomials on the left. That means the left side is a polynomial function. Then we can consider the function on the left, which is y equals 2x minus 1, then 4 minus 5x cubed, right? First of all, the degree, highest possible order of x, right, which is 4. And leading coefficient is 2 by -5 cubed. Again, don't have to calculate this as long as you know the sign of this number. Apparently, this is a negative number, right? So if you have a odd number degree and a negative leading coefficient, then the end behavior will look like this, right? Next step is to find this behavior in the middle. That depends on the zeros and orders. Okay, zeros is to let y be 0. Therefore, we can solve that actually x can be 1/2 with order 1, or x can also be 4/5 with order 3, right? Because it's simply been repeated 3 times here. Okay, so based on this information, we can have a sketch of the graph of this function. Okay, first of all, 1/2 is here, and 4/5 is to the right of the previous point. And as x goes from -infinity to the first 0 here, at the first 0, x equals 1/2 because it has an order 1. 1 is odd number, so it will cross this point, right? Go all the way to the next 0. Next 0 also has order 3. 3 is an odd number, therefore it will cross this point again, right? So basically, this is a sketch of this graph of the function. And our task is to find any interval that makes this function less than 0. So the zeros cannot be included, right? Because simply it will make this function be 0 rather than less than 0. So any interval that makes this function less than 0 is either x can be less than 1/2 or greater than 4/5 here, right? Therefore, we can make the conclusion x is less than 1/2 or x is greater than 4/5. Okay, have a look at this question and let me know if you finish.
Okay.
All right, let's see the next one. Okay, this time we have a ratio that is less than 0, right? And if we have already discussed, if you have a ratio between two numbers that is less than 0, this is actually equivalent to the product of these two numbers is less than 0, right? Do you understand?
Yeah.
Okay, so we can convert the ratio, we can convert the inequality involving a ratio to a inequality involving a product, which we already know how to solve, right? So let's call this asterisk. Then the rational expression is actually equivalent to the product of this expression is less than 0, right? And we have already know how to solve this. Usually we'll consider the function on the left, right? So let's say, because the left side is just a polynomial function, it's just simply a product of several binomials, right? So we can consider the function on the left. Y equals 2x minus 3 cubed, then times 2 minus x, then x plus 5, right? First of all, let's find its degree. Degree is the highest order of x, which is 1, 2, 3, 4, 5. And the leading coefficient is 2 cubed times minus 1, then times 1, which is less than 0, right? Okay. If the degree is 5, which is an odd number, the leading coefficient is less than 0, then this function will have an end behavior like this, right? Then the behavior in the middle depends on the zeros and their orders. Then let's check its zeros and orders. Okay, if we let y be 0, apparently x can be 3/2 with order 3. And x can also be 2, or x can also be -5 with order 1, right? So based on this information, we can sketch the graph of this function. Smallest 0 is x equals -5, followed by x being 2, followed by, followed by x being 3/2, then the largest 0 is x being 2. And remember that x being 3/2 has order 3. And then as x goes all the way from -infinity to the first 0, this function will look like this. Then at the first 0, because it has order 1, so it will cross this point and then go all the way to the next 0. Next 0 has order 3, which is also a odd number. So this function will cross this point and goes all the way to the next 0, which also has order 1. Order 1 is odd number, so it will cross this point again. Then this function has a sketch like this. Our task is to find any interval that makes this function less than 0, right? So first of all, zeros cannot be included. So we use circles to explicitly exclude them from the solution. And next, to find any interval that makes this function less than 0. And apparently this interval will do. Also, this interval will also do, right? Therefore, the final solution is x is either between -5 and 3/2, or x can also be greater than 2, right? Okay, have a look at this question and let me know if you finish.
Okay.
Okay, then let's have a look at the next one. Okay, next one, it seems that if you have a ratio that is greater than or equal to 0, it seems that this one is equivalent to the product of these two ratio is greater than, product of these two numbers is greater than or equal to 0. The question is this one correct or not? If it is strictly greater than or less than, there is no doubt about it, right? This one is always correct, because if you have a ratio that is greater than 0, that means both A and B are positive or both of them are negative, right? Which is equivalent to this one. This expression here also indicates both of A and B has positive sign or both of them are negative, right? So there is no doubt about this one. This one is always correct. And here the question is, if it is greater than or equal to, are these two expressions still equivalent? Did you consider this problem or not? So what's your opinion here? Okay, so let's consider this one. The product of A and B greater than or equal to 0. What does this indicate? This indicates A can be 0, right? Right?
Yeah.
So first case, A can be 0. Second case, B can also be 0, right? And the third case is both A and B are greater than 0. And fourth case is both of them are less than 0, right?
Yeah.
Okay, so there are 4 cases for the expression on the right. So how about the expression on the left? A over B is greater than or equal to 0. What does this indicate? So first of all, A can be 0, right?
Yeah.
And at the same time, B cannot be 0, right? Because B is the denominator. So this is the first case. Okay, second case, both A and B is are greater than 0. Third case, both of them are less than 0, right? So you can compare the left side with the right side. Are these two expressions indicating the same thing? Of course, they're not, right? Because for the expression on the right, B can be 0, but on the left, B cannot be 0, right? Do you understand?
Yeah.
So the left side and the right side are not same thing. You cannot use equivalent symbol here because they are not equivalent. Can you follow me?
Yeah.
Okay, so how can we deal with a problem like this? The method is simple because we know that if we have a strictly greater than, this is always equivalent to the product of A and B is greater than 0, right? We know this is always correct. Then we can actually detach this problem to two sub-problems, right? So let's call this asterisk in order to facilitate our discussion. So the original original inequality is actually equivalent to two parts, right? First is the ratio can be 0, right? Or there is a second part, any x that makes this expression greater than 0 is also the solution. Understand?
Yeah.
Because this symbol simply means the left side is either equal 0 or greater than 0. So we can consider this problem separately. So let's call this 1. Let's call this equation 1 and this inequality number 2. Then we can separately solve the equation and the inequality. So first of all, let's consider the equation. Equation number 1 is equivalent to, all right, so first of all, if you have a ratio that is 0, that's equivalent to the numerator must be 0, right? And at the same time, the denominator cannot be 0. Can you follow me?
Yeah.
Then we can further solve this. This is equivalent to, okay, the product of x plus 3 and 1 minus x is 0. That's equivalent to x is either -3 or x is 1, right? And at the same time, x cannot be 5. And this is actually equivalent to x is either -3 or x is 1, right? You understand?
Yeah.
Okay, so that gives us the solution to the first part, which is a solution to this equation. And do not forget, we have a second part. We need to solve the inequality here, but luckily we have already know how to solve it, right? For a ratio that is greater than 0, this is always equivalent to the product of these two parts. Is greater than 0, right? You understand?
Yeah.
And from here, we have already know how to solve it, right? Because the left part is just a product of 3 binomials. So it's a polynomial function. We can consider this function on the left side. Then we know its degree is 1, 2, 3, 3x, so degree is 3. And then leading coefficient is 1 by -1 by 1, which is less than 0, right? We know the degree is an odd number and leading coefficient is a negative number. That means the end behavior of this function will look like this. Then the behavior in the middle depends on the zeros and their orders, right? So let's find the zeros and orders. So if y is 0, apparently x can be -3, or x can be 1, or x can be 5. All of them, any of them has order 1, right? And then we can sketch the graph of this function. So -3 order 1, 1 order 1, and 5 order 1. Then end behavior will look like this. All the way go to the first 0, -3, because all of them has order 1. So this function will cross them, cross each 0 like this, right? And our task is to find any interval that makes this function greater than 0, right? Okay. Greater than 0. That means here. Or here. And zeros cannot be included, right? Okay, therefore the solution to this inequality is x is either less than -3 or x is between 1 and 5 inclusive, right? And according to the solution of the inequality here and the solution to that equation here. So let's call them let's call them 3 and 4, right? According to 3 and 4, the final solution is, okay, x can be less than or equal to, right? Because when solving the equation, we know x can also be -3, or x is between 1 and 5. Of course, according to the equation, we know x can also be exactly 1, right? And note here, there is no equal to 5 because you have x minus 5 in the denominator position. So x cannot be 5. Let's rearrange it a little bit. Okay, so this is our final solution. All right, have a look at this question and let me know if you finish, okay? Okay, let's see the next one. All right, for the next one, I have checked your solution. You simply multiply both sides of the inequality using x minus 2 and x plus 3, right? Did you do that this way?
Yeah.
Okay, why is this not correct? Okay, so if you multiply both sides using x minus 2 times x plus 3, let me ask you a question. Should this inequality symbol be greater than or less than? Which one do you choose?
I don't know.
Pardon?
I don't know.
You don't know, right? Because you don't know the sign of this number, right? You don't know if this number is positive or negative. That means we can't decide if we choose this one or this one. Understand?
Yeah.
That means you can't simply multiply both sides using the factor here, because otherwise, either you choose this one or this one is unknown. So we can't decide what to put here. So instead of multiplying both sides, using the common denominator, we can just move everything to one side. Okay, let's call this asterisk. This is equivalent, as I said, we can move everything to the left or right. So for example, we can move everything to the left. This is always correct, right? Move everything to the left, then left side is greater than 0. Then we can rewrite the left side using the common denominator. So what is a common denominator in this question? Common denominator is the product of x minus 2 and x plus 3, right? Okay, so if we use x minus 2 and x plus 3 as a common denominator, first expression is 2 times x plus 3, right? Then minus 2 times x minus 2, then plus x minus 2 times x plus 3, right? You follow me?
Yeah.
Okay, and this is greater than 0. This is always equivalent, right? Then we simplify the numerator here. So let's call because 2x plus 3 minus 2x minus 2 plus x minus 2 times x plus 3 equals 2x plus 6 minus 2x plus 4 plus x squared minus 2x plus 3x, that's plus x, then minus 6, right? Equals x squared. Then 2x minus 2x cancel with each other, plus x. Then 6 minus 6 cancels, then plus 4, right? Okay, therefore, let's call this double asterisk is equivalent to x squared plus x. Okay, plus 4, right? Over x minus 2, then x plus 3 greater than 0, right? And apparently, again, we have a trinomial in the numerator position, right? We can try to factor it or convert it to the vertex form to see if this number is always greater than or less than 0. And if you try to factor it, it's not very difficult. It's not very easy to do, right? Therefore, let's try rewrite this expression in a factored form. You can try using x plus 1/2 squared. And if you expand it, you will get x squared plus 2ab, which is x, then plus 1/4, right? Because there is no 1/4, so we need to subtract it and copy the rest of the expression here. Okay, so this is actually equals x plus 1/2 squared, then plus 15/4, right? Because this part is something squared, which is always greater than or equal to 0, right? Then plus a positive number, so the whole expression is always greater than 0. Can you follow me?
Yeah.
All right, because we have analysis like this, therefore, okay, let's call this number 1. Number 1 is equivalent to, okay, this time we know this part is always a positive number, right? If it is a positive number, the ratio between a positive number and another number is always greater than 0. So this is equivalent to the denominator here must be greater than 0, right? Can you follow me?
Yeah.
Okay, so actually the original expression is converted to this question, right? The two expressions have the same solution. So we can just solve this inequality, right? And actually the left side is a quadratic function, right? The leading coefficient is 1 by 1. So leading coefficient is positive. So basically we can sketch the graph on the left side. So this is x-axis. Leading coefficient is positive. So it opens up, right? And two zeros are -3 and 2. So basically the left side is a quadratic function that has a shape like this. -3 is here and 2 is here. Do you understand? Can you follow me?
Yeah.
Because the left side, one is a quadratic function, you don't bother to find its degrees, leading coefficient, and zeros. You can just directly using what we have learned for a quadratic function. First of all, it opens up. Second has two zeros, -3 and 2. Then you can directly find its sketch, right? Okay. Then our task is to find any interval that makes this quadratic function greater than 0. And apparently this interval will do, exclude 0 here. And this interval will also do, excluding this point here. Therefore, the final solution is x is either less than 3 or x is greater than 2. You understand?
Yeah.
Okay, let me know you finish, okay? Then we can move forward.
Okay.
All right, let's see the next one. Solve the inequality. It looks like this is a very complex inequality, right? And I have checked your solution. Again, you have multiplied both sides using the common denominator, right? Can you see why this is not correct? Because when you multiply both sides using x minus 3 times x plus 2, then you need to decide whether to change the direction of the inequality symbol, right? Because you don't know whether this number here is greater than 0 or less than 0. Therefore, you can't decide which one to use here. You follow me? Do you understand what I'm talking about?
Yeah.
Okay, therefore, do not blindly multiplying both sides using an unknown number, because you don't know whether this number is a positive number or a negative number, right? Instead, we can move everything to one side. For example, we can move them to left side. If you move everything to the left side, then you will have x plus 3 plus 1 over x plus 3 and over x minus 3, x plus 2 minus 2 over x plus 3 times x plus 2, right? And greater than or equal to 0. And note here, the left side, there are two terms, and both of them have the same denominator. So we can simplify it to x plus 3 plus 1 over x plus 3 minus 2, right? And x minus 3 times x plus 2 greater than or equal to 0, right? And this is equivalent to, again, we can simplify the numerator now. Numerator, we can rewrite the whole thing using the common denominator, which is x plus 3. And first term is x plus 3 squared now. Then plus 1, then minus 2 times x plus 3, right? And then over x minus 3, x plus 2, right? Greater than or equal to 0. Can you follow me?
Yeah.
Okay, then this can be further simplified to x. For the numerator here, we can just expand everything, right? X squared plus 6x plus 9 plus 1 minus 2x minus 6. Then divided by x plus 3, then divided by x minus 3 and x plus 2, right? So we can put these three denominators together. This is greater than or equal to 0, right? Can you follow me?
Yeah.
Okay, then let's simplify the numerator. Numerator is now x squared plus 4x. Then 10 minus 6 is plus 4, right? Over x plus 3, x minus 3, x plus 2. This is greater than or equal to 0, right? And note here the numerator can be rewritten as x plus 2 squared, then times x plus 3, x minus 3, x plus 3, greater than or equal to 0, right? Can you follow me?
Yeah.
Okay, now the task is to find the solution to this inequality, which actually we have already know how to solve, right? If you have a ratio that is greater than or equal to 0, usually we need to detach it to two different problems. One of them is an equation and the other one is an inequality, right? Understand?
Yeah.
Okay, so let's copy this to the next page. Okay, this is all inequality to solve, right? Okay, this is equivalent to, first of all, x plus 2 squared divided by x plus 3, x minus 3, x plus, oh, sorry about that, my fault, my bad. I forgot to consider the x plus 2 and x plus 2 here, right? It seems that we can cancel one, right? You follow me?
Yeah.
Okay, but the problem is, can we just cancel one without any consideration? So my question is the right side here is equivalent to the left side? Are they equivalent? Equivalent means they have the same solution. So are these two inequalities have the same solution?
No.
You know, right?
Yes.
Okay, you saw this, yes. But let's consider the inequality on the right. Can x be -2? My question is, can x be a -2 in this inequality? Or in other words, is x equals -2 a solution to the inequality on the right? Is it a solution?
No.
Why? Because solution means when you put this value into the inequality, it satisfies this inequality. If you put x equals -2, does this satisfy this inequality?
Hello?
If you put x equals -2, what is the value of the left side here? It's 0 over 1 by -5, which is 0, right? Of course, 0 equals 0 on the right. So it must be a solution to this inequality, right? You follow me?
Yeah.
So that means x is -2 must be a solution to this inequality. But on the inequality on the left, can x be -2? Can x be -2 for this inequality? Note here you have an x plus 2 in the denominator, right? So can x be -2? Follow me?
Yeah.
Laura, are you there?
Yeah.
So the question is, can x be -2 for the inequality on the left? It can't, right? Because when x is -2, the denominator will be 0. We can't have a 0 as denominator. You understand?
Yeah.
Okay, so that means x equals -2 is a solution to this inequality, but not a solution to the inequality on the left. So these two inequalities do not have the same solution. So they are not equivalent, right? You can't just use this symbol here. So you can't just cancel a x plus 2 blindly, because if you cancel them, in this new inequality, x can be -2, but in the original inequality, x cannot be -2. So we can't just blindly cancel it. In order to cancel it, first of all, we need to control that x cannot be -2. So if you want to use the inequality symbol here, you need to explicitly state that, first of all, x cannot be -2, right? Because you have an x plus 2 here. X cannot be -2 means x plus 2 cannot be 0. And if x cannot be -2, then we can cancel one of the x plus 2 here. Right? And this is greater than or equal to 0. Can you follow me? In this case, we have control that x cannot be -2 in this inequality, right? Can you follow me?
Yeah.
All right, so our task is to solve this inequality now. All right, let's call it 1. Let's call this 1 and this 2. And luckily, we have already know how to solve number 2 here, right? Basically, you have a ratio that is greater than or equal to 0. If you have some ratio that is greater than or equal to 0, we need to detach it into 2 different questions, right? So number 2 is equivalent to, first of all, x plus 1 over x plus 3, x minus 3 is 0. Which is equivalent to x plus 3, x plus 2 is 0, but x plus 3 times x minus 3 is not 0. And apparently the solution is x equals -2. Can you follow me?
Yeah.
Okay, so this is the solution to the equation. And do not forget, we have another branch. Or another branch is x plus 2 over x plus 3, x minus 3 can also be greater than 0, right? Let's call this number 3. And we have already know that number 3 can be equivalent to the product between the numerator and the denominator is greater than 0, right? Okay, then we consider the function on the left because it simply is a polynomial function. Then we find its degree. Degree is highest possible order of x, which is 3. And leading coefficient is 1 by 1 by 1, which is greater than 0, right? And then we find its zeros. Zeros are x can be -2, x can be -3, or x can be 3. All of them with order 1, right? Then based on this information, we can sketch the graph of this function. So -3, -2, and 3. Degree is 3. Leading coefficient positive. That means this function will have any behavior like this, right? So x came all the way from -infinity to the first one, cross the first zero, then cross the second zero, then cross the third zero, go all the way to the positive infinity, right? And our task is to find any interval that makes this function greater than 0. And apparently this will do. This interval will also do, right? Therefore, the solution to this inequality is x is either within -3 to -2, or x is greater than 3, right? So let's call this number 4, and this one is number 5. Therefore, according to number 4 and number 5, the final solution is x is greater than -3, less than or equal to -2, or x can also be greater than 3, right?
Yeah.
Oh, made a mistake here. And do not forget, according to the expression 1 here, x cannot be -2, right? Therefore, the solution of x equals -2 must be withdrawn, right? Because if x is -2, that will make your denominator be 0, right? So x be -2 cannot be the solution, part of the solution. So we do not include -2 here. The final solution is within -3 to -2, exclusive, or x greater than 3. So this is our final solution. Okay, have a look at this question and let me know if you finished.
Okay.
All right, then let's have a look at the next one. Try to prove a squared plus b squared over 2 greater than or equal to ab for any real numbers a and b. Okay, we can think this question like this. In order to prove sum of a squared and b squared over 2 greater than or equal to ab, we need to improve. So pay attention to the direction of the arrow here. In order to prove the left side, we need to prove a squared plus b squared greater than or equal to 2ab, right? Because if you can prove this, you can just divide both sides using 2. Then you will get this one, right? So if you can prove this one is always correct, then the left side is always correct. Do you understand?
Yeah.
So how do we prove this? In order to prove this, we need to prove that a squared plus b squared minus 2ab greater than or equal to 0, right? Again, pay attention to the direction of the arrow here. If you can prove this is always correct, then this one is always correct. Understand?
Yeah.
And how about this one? So we need to prove this one is always correct, right? And in order to prove this one is correct, we need to prove that left side is actually a minus b squared greater than or equal to 0, right? We need to prove this one is always correct. Do you understand? Again, pay attention to the arrow here. Can you follow me?
Yeah.
Okay. And this one is apparently always correct, right? Because you have something squared. Something squared, a and b are real numbers, then the difference between a and b must also be a real number. Real number squared is always greater than or equal to 0, right? So let's label it with asterisk. You can say that because asterisk is always true for any real numbers a, b. Therefore, we have a squared plus b squared over 2 greater than product of ab for any real numbers a and b. Okay, do you understand the logic? Because this one is always correct. If this one is correct, then this one is correct. If this one is correct, then this one is correct, right? If this one is correct, then this one is correct. Then we can prove this statement is always true for any real numbers a and b. Can you follow me?
Yeah.
Okay, let me know if you finished. Then we can move to the next one.
Okay.
All right, then let's consider question 8. You can follow the same logic, right? Actually, on your paper, this should be x greater than 0. This is a necessary condition, not x. X cannot be an arbitrary real number. X must be a positive number, okay? Prove that x plus a reciprocal of x is always greater than or equal to 2 for any x belongs to real number and x is greater than 0. Okay, we can say that in order to prove that x plus 1 over x greater than or equal to 2. We must prove. Okay, let's consider if because x is a positive number, right? So if we can prove that x squared plus 1 greater than or equal to 2x, if we can prove this one is true, then this one must be true, right? Why? Because if this one is true, we can just divide both sides using an x, right? Because x is positive, so we don't change the direction of the equal symbol here. So if we can prove this one correct, then we can just divide both sides using x. Then we have x plus 1 over x greater than or equal to 2. That means if we can prove this one correct, then this one must be correct. Can you follow me?
Yeah.
Okay, so pay attention to the direction of this symbol here. This means if we can prove the right side is true, then the left side is true. That means right side indicates the left side. Okay, and how do we prove that this expression is true? In order to prove this one is true, we need to prove that x squared minus 2x plus 1 is always true. Greater than or equal to 0 is always true, right? If we can prove this one is true, then this one must be true. Can you follow me?
Yeah.
Okay, so how do we prove this one is always true? In order to this one is always true, we need to prove that x minus 1 squared greater than or equal to 0 is always true, right? And note here, x is a real number, plus 1 is also a real number. The real number squared is always a non-negative number, right? So let's call this asterisk. We can say because asterisk is true for any x real number and x greater than 0. Therefore, if this one is true, as we have discussed, this one must be true, right? And this one must be true, and this one must be true. Therefore, we can prove the statement that x plus 1 over x greater than or equal to 2 is true for x belongs to real number and x greater than 0. Okay, have a look at this question and let me know if you think.
Okay.
All right, then let's have a look at the next one. Actually, sorry, my typo here. I lost a sentence here. Then what is a plus b plus c is a question in question B. Okay, so first of all, let's have a look at question A. If x and y are real numbers such that x squared plus y squared is 0, then what are x and y? Okay, so a real number squared is always greater than or equal to 0, right? Y squared is always equal to or greater than 0 because the sum of these two non-negative numbers is 0. That indicates both of them must be 0. Otherwise, the right side cannot be 0, right? So for the first question, x must be 0 and y must also be 0, right? Okay, for the second question, we can use the following, we can use the same principle. First number squared is always greater than or equal to 0. Second number here is always greater than or equal to 0. Third number here is also greater than or equal to 0. But we know that sum of these non-negative numbers is 0. That means this number must be 0. This second number must be 0, and third number must also be 0, right? That means a plus 3 be 0. And b minus 7 is also 0. And c minus a is also 0. That gives us a is -3, b is 7, and c is a, which is also -3. Okay, let me know if you finish, okay?
Okay.
All right, then let's have a look at the last one. Last question actually asks you to prove that if we have two numbers, x and y, the x plus y over 2 is called the arithmetic mean, right? And the product, the square root of the product of xy is called the geometric mean. It simply asks to find that for any two negative numbers, such as x non-negative, y non-negative, for any two numbers, we have the arithmetic mean is always greater than or equal to the geometric mean of the two numbers. This is a question. Okay, for any x non-negative, y non-negative, prove this one is always correct. So how can we do this? So in order to prove this, okay, we can use the same logic. In order to prove this, we must prove that x plus y equal to or greater than 2 times square root of x times square root of y, right? The reason why we can rewrite like this because x and y are both non-negative, right? Do you understand? So if we can prove the statement on the right is correct, then the left side must be correct. Can you follow me?
Yeah.
All right, so how can we prove the right side is always correct? So in order to prove that one is correct, we need to prove that so note here x can be rewritten as square root of x squared plus y can be rewritten as square root of y squared, right? Why? Because x and y are non-negative. That's why we can rewrite them in this way. So as long as we can prove this one, as long as we can prove this one is correct, and this one is correct, and this one is correct, right? You follow me?
Yeah.
So in order to prove this one is correct, we can move everything to the left. Then as long as we can prove this expression is always true, then we can prove this statement here is true, right? Can you follow me? Can you follow me?
Yeah.
All right, so how do we prove this one is true? In order to prove this one is true, we need to prove that square root of x minus square root of y squared greater than or equal to 0, right? Because if we explain that, this one is actually the expression on the left here, right? As long as we can prove this one is correct, then 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 this one is correct. It's like a chain reaction, right? Can you follow me?
Yeah.
Okay, so Because x is a non-negative real number, y is also a non-negative real number. So this is a real number, right? A real number squared, of course, is always greater than or equal to 0. So we can say that because, okay, first of all, let me remove this first. This is just a restatement of the original problem, right? Let's remove that. So here we can say because for any x greater than or equal to 0, y greater than or equal to 0, we have, no, so we can say asterisk is always true. Okay, as we have discussed, it's like a chain reaction. If this statement is always true, this statement indicates this statement, right? If this one is true, this one is true, then 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 this one is true, right? Therefore, if we have proved that the asterisk is always true, therefore x plus y over 2 is always greater than or equal to square root of product of x and y for x greater than or equal to 0 and y greater than or equal to 0, right? Okay, in other words, for any two non-negative numbers, the arithmetic mean is always greater than or equal to the geometric mean. Okay, this is a quite important conclusion. You follow me?
Yeah.
Okay, then I'll upload my notes to Google Classroom. Okay, you can refer to my notes if you still don't know how to solve any of them. So next assignment, I'll give you some similar questions to practice again. Okay, you can download them from Google Classroom probably later today or early tomorrow. Understand?
All right. Thank you.
Okay, if you don't have any question, you're free to leave. Bye.
Bye. Thank you.
No problem. Bye.